what is the one biggest misconception or the problem web or cloud engineer face when they try to deploy model on the edge devices?
I know a lot of folks didn't get into core machine learning, so they feel like they're stuck into the deployment phase a lot.
I know the TensorFlow Lite used to be the name, but I see they have recently transitioned from TensorFlow Lite to LiteRT.
So EdgeAI experiences should be your first priority because customer getting confidence, right? My data is not going anywhere. In the last 5 years, there's a trend change in AI a lot. There's a lot of huge investment in AI came around in that way. I always say, think like an engineer first before you're thinking like an AI engineer first.
You also mentioned the quantization because that is treated as a silver bullet. But when you actually quantize a model to fit into a mobile device,
A lot of times people think PTQ is the only technique that you should use to quantize, but sometimes if you're not able to understand your data properly, you can't able to fit it properly on the model side.
so what is the actual benefit specifically from the enterprise's perspective?
So edge AI capability can be sooner or later will be future. Whatever device that you have right now, it's an edge device. After 5 years or 10 years maybe, people don't distinguish between what is for a software and what is hardware.
Welcome back to another episode of Techie Talks with Kuldeep. I am your host Kuldeep Singh. Today we are excited to have Mr. Kartikeya with us. Kartikeya is the one who has not only worked in the ML space on the models, but also, running them on the edge. As you know, running on the edge brings, the different problem and the different challenge. Kartikeya, welcome to the show.
Thanks, Kuldeep, for inviting me. And hey, everyone who was seeing me. My name is Kartikeya. I'm a senior developer advocate and a senior engineer at Qualcomm. And I majorly work towards the model optimizations at the edge. And not only at the edge, we can say on the premise when we talk about cloud infra also. So it's great to be here and love to share my insights with the community and all of your audience.
Thanks, Kartikeya. And I think you bring, that vast expertise because you are the Google developer expert in AI as well as in the cloud, which means when we talk about, building these big models and all. But also during that journey, you also started exploring TensorFlow.js, right? Which means pushing machine learning into the web browser. And now you are also optimizing the edge AI, specifically while you started working with Qualcomm. Tell me, what is the one biggest misconception or, the problem web or cloud engineer face when they try to deploy model on the edge devices?
Yeah, I think so. A lot of folks, because I know a lot of folks didn't get into core machine learning, how actually a machine learning model works. So they seems to feel like they're stuck into the deployment phase a lot. But when we talk about basic modern deployment also, because we know model are way too big. Yeah, classical model, we can obviously do a basic deployment. That's not an issue. There's a runtimes pretty much up there, LiteRT and XGTOS, where you can use it, right? But when we talk about the maybe Gen AI models, which is present right now, people don't know how to make it very smaller, which is called in a technical terms quantization, right? Or when we talk about pruning techniques or those kind of techniques, right? So a lot of folks didn't know that, and a lot of folks didn't know what is their use case and why they are using that particular model for that, right? So sometimes people use general model to implement some specific use cases. If they can fine tune that particular model, and it obviously, if you're fine tuning a model, you are making the model more smaller also, apart from the quantization work and all. So I think so. These particular thing people didn't know. So when I started with TensorFlow.js as an open source contributor, I get to know about how TensorFlow.js work under the hood, how the architecture resembles around it. A lot of folks just want to take the model and say, just give me the function to directly inference or deploy it. But I think so. It doesn't go well with that because if you didn't know the framework or the how the inference engine works properly, you didn't know how you can implement more better. So even though I know your priorities may be web, mobile, or in general, whatever the application that you're building, but I think so some context of framework, how our architecture is working under the hood for inference is very important. A little bit. I'm not saying go into the depth, but if you know a little bit architecture, so it will help you to deploy the models more faster in that way. Yeah.
You are right. And, sometimes when I talk to the engineers just think, hey, it is like, the model which was working on my machine. I'll just go ahead and deploy, make it bit lighter, and then it will start working. But then they start facing the problem, either, the accuracy, because they reduced, the weights this much that the accuracy started dropping, or it is like, overflowing and always like killing your browser or, the web app, because it is a significant change.
Like if we talk about in general, like so at Qualcomm we are building a platform where you don't have to do that so much of internal cost to the architecture. It's our tech to build on it, but at least even you should know at least some knowledge around the inference engine, and the reason is just like you could get it better, scale it up in that way, right? You know how many devices your model will be working, so you should have idea about it and how it could deployment phase and all. So after that basic learning, I think so any developer can build on top of it actually. Yeah.
Yeah. And during the initial TensorFlow days, I know the TensorFlow Lite used to be the name, but I see they have recently transitioned from TensorFlow Lite to LiteRT.
Yeah.
Like, beyond the name change, is there any significant change under the hood? And how does it impact, the engineer which are building now the app? And
Yeah.
also, since you are working it with the Qualcomm, how does well it interface with that strategy?
Yeah, so light RT, just the name is changed, but under the so think light RT just like a front end, and under the hood our runtime, which is called Qualcomm AI Engine Direct or QNN, is under the hood as a runtime. So they just giving access to a more like APIs front end, but under the hood for our, if you're using any S25 Ultra or any Snapdragon devices, like I have my S25 Ultra here. So you can basically take a Gemma model, for example, and try to inference on it on NPU without any internet. So it is working very locally, and you don't have to go anywhere else. Like you just, your privacy is with it at your hand. I always say in our tech industry, there's a saying, right? Uh, Privacy is a myth, but at Qualcomm, we are here to say, no, it's not a myth. Privacy at your hand. And it's your responsibility if you're giving your privacy to someone else. But apart from thing, the core focus of LiteRT is just like a front end. The back end runtimes, which is happening on hardware accelerators, that is our like chips, Snapdragon chips, is onto us. So LiteRT just give you an API access to that, but under the hood, QNN is only working on with on like interacting with our hardware in general way. So think LiteRT, or if I talk about there is another internal sub directory framework called LiteRT LM, which supports language models also. You can run that particular language model on on NPU purely. So you just have to be very go on your SoC's version, that is called system on chip version. Suppose I have this, it's like 8750. That's the idea of SoC version of S25 Ultra, right? You just have to convert that .tf Lite model or .lite Lite RT or Lite RTLM model to that particular SoC version. And it can be done using our platform called Qualcomm AI Hub. It gives you a strength to convert the SoCs. So you have a lot of devices. So our chips in automobile, laptops, mobiles, IoT devices. Now, if pretty much those don't know, or Qualcomm already acquired Arduino also. So our chips are also now in Arduino UnoQ. So you can do some EdgeAI inferencing on IoT devices also. It's not like we are restricting you at some first place and something like that. So this give you a more advantage. And why we are seeing is because we are know there's always on the social network terms, there's always someone say like, "Yeah, my data is leaking and all that." But right now we are giving you that opportunity. Or if you are building, if you are engineering manager and if you're building to make it more experience, more better, I think so edge experiences should be your first priority, because customer get in confidence, right? My data is not going anywhere. My data will be with me only in that stance. So that can be a good opportunity to a lot of engineering manager to implement some edge AI experiences in their applications.
No, you are right. And I think even given how the AI adoption is increasing, if we do have the AI component at the edge as well, now we're like, rather than, just treating those edge devices to send data to a central place and then making, those AI models, etc., it is good that you do have, the AI capability at the edge itself, so that rather than, just keep pushing the data, you are just making the decision and maybe then just forwarding, the related information to the central place.
True. So like there's always a debate, I guess some decades back. Even on a decade when we say like AI is not that existence in that way, in the last 5 years, there's a trend change in AI a lot. There's a lot of huge investment in AI came around in that way. But I still think, because when I interact with a lot of developers in hackathons in general, like when I'm interacting with an conference or something like that, they always approach on an AI solution. And I always say, think like an engineer first before you're thinking like an AI engineer first. Like how you're optimizing your algorithms. Is it like classical algorithms, or it's like a machine learning algorithm, which give you the better results with less cost in it? That's the main thing. And even people didn't understand, but I can say Edge AI have a lesser cost comparatively to cost of cloud when we talk about in a scenario like, so let's take an example. Like I guess a year or 2 years back, I guess Sam Altman tweeted, I guess there's a Ghibli images creation generation created in Twitter or X, right? And Sam Altman tweeted, "Please do not generate so many images. We are running out of a lot of water and energy on our GPUs, and it is heating up so much." And when we think in that way, sometimes we ask very simple question to ChatGPT. Maybe suppose I make a statement. Can you make it grammatically correct? No, it is very simple. It's a very simple statement. You can do it. And now we thought of, it's a very simple task. Can we do it on edge also? Why to basically use that kind of GPUs for that? And if people know about it, those experiences already, they didn't have to go to, maybe suppose, to chat GPT to basically burn those kind of GPUs. It's like an optimization layers to a lot of, like, to the industry also and the people also. And when people say why to use edge, I always say privacy is always in it, and you don't have to burn a lot of GPUs for that, just for the simple task, right? We know when we're doing training is another part to it, or pre-training is another part to it. But when we talk about inferencing, it still need a lot of cost when we talk about cloud, because it's not like a one GPU is in using for inference. It's a lot of GPUs standing in one set is actually seen in use when we are doing inferencing, right? So if that kind of architecture can get at your phone or at your local device or at maybe on your laptop also, that can be a good starting point also. So that's my intake to it. And I basically built a small app for that, like just to test like how it does work or not. So what I created a web ID. It's on web. It's an ID. It's an agentic ID using my Gemma model. I use a Gemma base, I guess, 2B model. And it's working locally using with my web GPU API, right? It's using my local GPU, and it's using like on my web basically. And it's giving me, even the contextualization is always an issue. We know that contextualization and memorization is still an issue with LLMs or SLMs for now. But still, getting an output responding very quick, it's not like lagging also. That's give me more opportunity towards to work more on the edge. Like, yeah, I think so. If this can be implementable, maybe at some time, cursor or like a lot of anti-gravity and more like IDs can be get into these spaces on the edge part basically. Obviously, you will not get the right output, if I will say, but I always say, and I think so. I'm listening to, I think so, KV's model founder, and they say it's not about the model; it's about how you are making it package. Packaging very very important in model, and we all know that when we are deploying the models. So sometimes you have a best model, but the output is not good because you're not able to package it properly while doing the deployment part, right? And this is very important part of it when we talk about, like, even I talk about with engineering managers, senior engineers around it, and they still face some issues around it. And the reason is being because maximum people think machine learning engineers are is purely on research, which is good. It is in research basically. But when we talk about the deployment part, I think so. If maximum people when I interact with, they didn't know about the model optimization. Maybe it can be quantization, pruning, or like any other techniques out there, right? And this is the core part of optimization. And I know a big model can be fit into one stance, and it can be possible, but it just like people don't know about it. Like, so that's always my case when I'm talking to a lot of developers around it for that. Yeah.
You are right. Like still making it productionizing is still one of the biggest problem. And when we come to the edge deployment, and you also mentioned the quantization because that is treated as a silver bullet. But when you actually quantize a model to fit into a mobile device, how much roughly the task accuracy or the reasoning capability developers actually sacrificing?
Yeah. So there is 2 to 3 aspect to it. So obviously, when we talk about quantizations, there is two quantizations called symmetric and asymmetric quantizations, right? And generally, when we talk about the practical use cases, it will goes to asymmetric quantization generally. And those who didn't know, just it's just like uneven type of quantization. That's called asymmetric quantization. There is no reference point when we talk about asymmetric quantization. So there is two techniques to it. One is obviously PTQ, that is called post-training quantization, right? And a lot of times people think PTQ is the only technique that you should use to quantize, but sometimes, a lot of times, when the data is not segmented properly, right? So it fail a lot. So even though if suppose the base model have 90 or 95% accuracy, it can drop at least 60 to like around 50 to 60% of accuracy also. Even though you are using PTQ, which is called the standard code for maybe a model optimization in that way, right? But still not. But so there's a lot of more techniques, but before getting into that, again, there is a quantization aware training, that is QWT, right? After the quantization, you can do a basic training so that you can basically fine tune it more better. And the reason is being after, and AWT is always happen after, you can say after PTQ only. It's not before that. It's after the quantization basically, and it generally does by the like those who are building the like who are using the models or who are building the models around it, right? Now these are two techniques, but I can say these two can also fail on optimizations part and all. And it's not about the model is the issue, it's like a data is the issue. So suppose when we talk about the when we go on the probability distribution graph and all, right, probability density graph, and if there is any data point which is very not into the scale of that particular graph and it's very outside of the class, so generally what generally models do, models basically change the reference out of it. And when the reference extended to suppose positive x-axis, suppose I'm taking an example, the center data part becomes left, it's not center basically, right? So data got fragmented and created some kind of noise in the model itself with that particular data, right? So this is always an issue, and how we can solve it is always a different implementations of algorithm, you can say. People generally what they do a partial differentiation so that you can make the whole gradient to the center of the whole graph, and this is always an issue. So I always say, whatever you are doing, if your data is not correct, even you make your model architecture more better and the inference engines are also good. But yeah, if you're not able to understand your data properly, you can't able to fit it properly on the model side. And again, when you do inferencing, you get a response very vague, like vague response also you're getting, right? So it happened with a lot of benchmarking also when you can see in that way. So generally there's a quantization method called add around, which basically rounding of the, suppose we are saying we have 127 and 128, and in between suppose we have 127.5, right? So generally we can switch to 128, that's a general rounding. But when we go deeper on the maths level, suppose we have 127 127.5123, right? Then it will go to 0.52, and it is very important. Even though if as a human we say no, no, let's go to 128, why to switch to like just precision low and all that. But when we multiply that part to maybe to some like to maybe same number, and if you're multiplying that with 120 into 120, it give you different altogether different results out of it. So these kind of precision is also very very important, and people doesn't go with it. They say okay, let it go, this small they change, what doesn't matter, like it's matter a lot when we get the response out of it, right? So that's a major part that I and my team is trying to fix a lot of times, and telling like advocating about people about quantization in a more better way, how you can optimize a model more better, because people doesn't know these some instinct around it. So yeah.
No, you are right. Like there are n number of the detailing if you start going into this domain, and that's I think people still need to understand what is exactly the edge AI and how to make it work. But tell me one more thing. One thing is like the compute, right? So you can still have like the more capacity there, but then it is also coming to the power utilization, specifically with the batteries and all where we operate. What the architectural choice, for example, even if you take the Google Gamma, which is explicitly engineered for the local deployment, what choices they make that they are actually usable on the mobile platform without killing the battery.
Yeah, so obviously we can discuss on the architecture part of it, maybe in different part to it, maybe platform architecture, what they implement in that way on the Gemma models and all, right? But over the point is always the ops, or when we talk about kernels, which is have a custom kernels part of it, because sometimes some ops doesn't support it properly, right? And I know those who are into writing kernels, they pretty much know what is the value of writing kernel, even though it's kind of hard to write the kernels from scratch and all. At some like if you can write basic kernels, that is not an issue out of it, right? But when we talk about some kernel which is very hard to implement, maybe let's take an example, sigmoid function. Even though it's very simple, implementing on maybe a hardware layer or like assembly layer is very hard over it, right? And like for an example, we like at Qualcomm we recently acquired a company called Mojo, like modeler, which is have a Mojo as a language, which gives you that power to basically write kernels on top of it. So my major context towards it, how when we talk about Gemma as a part, it's quantize. You can quantize Gemma also. That's not a problem with it. But the runtime is always an issue around it, and we at Qualcomm solve that. When we talk about our runtime called QNN, right? It helps you to inference it properly, and we actually give them a profiling results also before that, before inferencing to it. So we have a product called Qualcomm AI Hub. So if you go there, you just upload your custom model. You will get your compilation part, profiling, inferencing, all the details at once. So you can do it. Suppose you didn't have S25 Ultra, for example, and want to deploy something, you can go to AI Hub. You can upload your custom model on AI Hub. It will give you the profiling details and inference detail also on the cloud. It's using cloud for that, right? But you get it right. Okay, this model, so this one is right for my users, and maximum users of mine may be using this kind of phones only, for example, or this kind of devices. So you can ship this particular model to your maybe to your devices or something like that, like on your production side, right? And so people can use your edge experiences on that particular front. People generally very hitchy around, should we ship this thing to our production, even edge AI, is it like viable or not? Do we lose our customer in that? But for that also we give you one more option. It's free of cost. You didn't have to buy anything. That's the point. Like if you want to actually use it, like our tech you can use firstly in our platform, and if it fits well, you can buy another phone and try the whole experience on the front end part of it. But on that particular end, you will get the whole profiling results of it, how much time it is taking, how much the model size, how much model size actually inferencing locally in that way. So you give all the details from the logs part of it. So that's the part when we talk about even Gemma. Runtime is always an issue for a lot of folks because NPU is the very, I can say NPU is the next big thing, at least for the inference engine. I can say aloud, right? Because I'm working on that particular part. So models have two part to it. One is architecture, and it is very important. And again, architecture is very research oriented, right? How we are optimizing it to make it more better. Like Kiwi optimization is, can we say, even Gemma have a more better optimization on the open source part to it, right? But at the end of the day, those models are able to run properly or not on the inference part is very important. And I think so that's where QNN comes in, and it can actually help you better to run faster than ever, actually. Yeah.
So you are right. There are like still lots and lots more detailing which an engineer needs to understand. And glad to see, right? There are platforms which are available, which is doing the ease for these developers, so that they can develop more and more such model. Tell me one more thing, which comes to my mind is about the RAG implementation. Like RAG became very much important, and I think we see the production implementation already. But is there a way we can set up the local rack on the edge platform as well? And can these devices actually handle those vector search and lightweight embedded before giving the production grade result?
Yes, you can do it. I already did it. I implemented a local RAG. So it quite possible. And accuracy, if suppose I can take in consider if you are doing on cloud, maybe if accuracy is around 96, 97% or something around that, I can vouch for it. It will give you around 92, 92% easily. Easily, I'm saying the minimum accuracy basically. And it again, it depends on how you fit the model basically. Right. So it is very easy. You can easily do it. You can take any vector search database, for example, like I explore Couchbase as an instinct to it. So you can use vector DDB for that. You can do vector search locally, and it will use your NPU for local for if you want to enhance it, or like GPU also. You didn't have to go every time NPU also. But if you think like your use case is not that big, so CPU GPU have that capability to take an inference, and very easily they can do it. It's not like very hard encoded in that way. So it is quite possible, and I did it. So if anyone wants to go, you can go to my GitHub repo. Like they have a proper listed with a lot of examples. So if anyone wants, they can build on top of it. Just fork my repo and they can build on top of it. So it's quite possible. It's just like you have to implement a, so Couchbase have, if I'm not wrong, Couchbase have a called Couchbase Lite, which is a local database specifically for vector design. They built it in that way. So it's still using a local storage, but have a created the vector space out of it. So you should have a more memory, like more space for that storage at your phone. If you're using at your phone, for example, or laptop, whatever you say, right? So it can use local RAG. It can be quite possible to implement in that way. Yeah.
No, you are right. And there is like, the another question also come, and because you have worked also in the uh, cloud space as well, that hey, there are like for everything, every model, there is like cloud AI API available, right? So what is the actual benefit specifically from the enterprise's perspective, rather than leveraging this API directly? Why do they wanted to spend the engineering hours on optimizing the edge AI model instead of just calling an API directly?
Yeah. So there is a lot of benefits on enterprise where they are, I guess a lot of companies are pushing edge AI right now. And the reason is very quite simple. It's like to reduce their cost, right? And they get it for complex when they have to use. So we are not saying we are competitor to cloud. We are not saying that. We are it's a, like a hand in hand thing. We are saying the future is hybrid solution. That means cloud and edge both, right? Now, suppose, let me give an example, and I give a lot of this example in my talks also. So suppose you are using a social media, for example, Instagram, right? Now, we know whatever reels we got feed in, right? We sending some data, it can be comment, it can be like anything, right? Now think that the recommendation that is happening, it can happen locally, a metadata generated out of your data. It's not your data, it's a meta generated data basically. And it's sending like this should be the reels, it should be recommended. And again, it's going through the cloud. So the recommendation part where your data actually is in use. Even everyone say like comment is there, we are sharing the data in a way, but still the experience part, like the actual recommendation part is not going to your data. Like that data is not going, it's converting into metadata. So it is a kind of a question, like a kind of a problem statement we can say on the hybrid part, where we have both edge and cloud. Some data is not going, but some data is going. But the point is, some data is not going. That's an important question out there. That means there's a quite possibility in future that edge AI part can go more and more better as we're going up, right? So I think so that can be a good opportunity in a lot of folk when we talk about why enterprises actually focuses on a lot this. Simple question is they want to reduce their cost. And if edge AI can give them a better like for the simple task, if they can give it in that way. Suppose let's take an example for OpenAI. If suppose you are going for chat GPT, you're just asking any question. If the internal tool say like it's a very simple question, it should go to the edge AI, it will go to edge. And if you know it's a very complex task, you're doing deep research or something like that, it should go to the cloud. Simple thing, right? So this kind of nuances also reduce their cost also. People are still using chat GPT for that reference. But edge AI capability, because phone now, I know a lot of phone doesn't have those capability till now, but as we are going in 3 to 4 or 5 years, I think so a lot of folks have, everyone have those kind of chips in their phone. So edge AI capability can be sooner or later will be future. That's what I'm seeing right now in every device. Not I'm talking about mobile or laptop. It can be your automobile. It can be your IoT devices. It can be your XR devices also. So whatever the XR devices that you're seeing right now, maximum have chips of a Snapdragon only. Talk about maybe like the Meta glasses, right? We talk about XReal, Android XR glasses, all chips are from us only. So inferencing on that part, on your glasses is also a new genre that we are seeking on new compute. Everyone say like there's always us talking in um, San Francisco. Maybe maybe mobile can be replaced with XR devices because it is very easy if you have a while like wearable watches or suppose the XR glasses. So your whole scenario of interacting internet is become very different to it. Right. So experience of a internet may be changing in some years or like in a decade, at least what I'm seeing right now. But this is always a good opportunity, like how we can make it more better and better on that part. And I think so. if I'm not wrong, the Exeter CEO, I guess they are building on the internet experiences, on the new company on the internet experiences. So I think so this is a very good chance if you actually get into the space to get more better new experiences for internet for the users. So that can be a good opportunity to a lot of folks when we talk about edge in general in that way. Yeah.
Mhm. No, you are right, and that's where I see more and more companies and even the engineers wants to specialize in the edge AI because as the AI becomes part of your day to day work, right? So it is still some people are using it. When more people will start using it, then you start seeing the explode of the information. Then there like a information keep needs to flow from different models, from different data center and all, and these type of thing. If you can handle it by implementing, the specific your setup, you can reduce cost, of course. But to me, it is also reducing the latency, providing the quicker result, which is also becoming the need of the hour. All right. So Kartikeya, I know you have moved your journey from a software developer to the AI developer, but let's say if someone just want to specialize in the edge AI as well, what is the exact tech stack they need to learn and master in upcoming months?
Okay, it's a very broad question according to me, if you'll ask me. But from my experience, at least built on top of the frameworks that already have, I guess that give you a better understanding if they want to work on Edge AI specific, right? So when we talk about runtimes like LiteRT, ExitDodge, even the thing is that's a very quite funny thing is like for on the AI Hub side, we have all the runtime under the hood. So it's not like it's like for us all for it will be easy for you. So you don't have to go to runtimes also. You just have to go to AI Hub, just select whatever the runtime that you fit in, and the model you get the model for that optimized model at least, right? So my take is always focus on two things. Obviously, core machine learning is always very, very important. People doesn't go it well. I think so. Maths is very, very important. I can say quantization is good, but yesterday I gave a talk, and a lot of folks I am seeing like they are not able to getting the maths out of it, and the reason is being because they didn't good with the core ML part of it of that. So my take is we be very specific with core ML, but apart from it optimization, model optimization is always a different cake of it. But when we talk about it, quantization, just good with quantization, how to quantize the model, right? What is pruning technique? What are the different techniques? How you optimize the model, right? And when we talk about runtimes, they have a lot of runtime like QNN for that, say LiteRT. Under the hood, QNN is only working for that if you go for mobile development and all. IoT, we have called a company called Edge Impulse. It's a Qualcomm company, so you can download the model. It's a like very transfer learning basically setup of dashboard. So you just have to pay whatever model that you want to build. Classical model can build easily, and you can deploy that particular model easily on Arduino UnoQ. And it is not on UnoQ. When we talk about Edge Impulse, you can take any hardware that you are. If maximum hardwares are into the ecosystem of Edge Impulse, so you can do that also. And apart from it, XR devices, Android XR is a good way if you want to do explore it. And again, the point is on the both side, we talk about meta classes, that is Ray-Ban meta classes. They have a meta have a total different SDK, but still all the chips are so it's influencing on our runtime in a way. So that can be a good starting point for a lot of folks. But for my initial take, if anyone wants to say, I guess laptop and mobile can be a good starting point to build applications as of now, so that you can well verse with it and then you can optimize it. Because when we talk about IoT and XR, the XR device still, because it is a very low end power compute devices, so it is very hard for you to fit to maybe a Gen AI model right now on them, right? But my take should be always take any mobile. I think so. Mobile and laptop is with everyone, so it will be easy for you to basically build on top of it, right? So if you talk about my laptop, also I am using Surface laptop, and it have an Accelerate chip, which is a like Snapdragon chip only, basically. So the broader you go, you can see Qualcomm in it in everywhere in that way. And it's still not the we are surrounded with devices at the end of the day. And I think so everyone should have a advantage how you can make every device is more intelligent, right? That's generally how human race built on top of it, right? So I think so that can be a good starting point. A lot of folks, I guess, mobile and laptop and working on those on those runtimes. It can be LiteRT, it can be exitors, it can be QNN, or using AI Hub for that sake to build on top of it. So that can be initially good starting point for that. Yeah.
You rightly said, and I think the another good aspect would be like, hey, whatever models etc. which you have built or you have used, try start using them, or try it on the mobile devices. That is something we'll have, and then you start seeing the differences, and then you can focus more on, hey, is it like there to differentiate the problem? Is it the runtime problem? It could be also in the core language, because you might have written the code in the Python, but then you need to compile it for C++, and then you can go into the hardware, right? Because then that's become the last layer, where you could understand, is it like really a hardware related problem, or is it really the software related problem you implemented? All right, Kartikeya, these were the question in my mind. Anything more you would like to share?
Like, I think so, folks. A lot of folks think like Edge AI is very specific for IoT, and I don't feel like everyone think like in that way. But whatever device that you have right now, it's an edge device, right? So don't feel like when. So I know it's started from maybe, if I'm not wrong, a decade back, because people who are working on edge is purely IoT folks only, because they are very hardware focused only. No, I think so. What software and hardware is like merging a lot. So this is my take. I think so. If after 5 years or 10 years, maybe people don't distinguish between what is for a software and what is hardware, because it is very submerged in one in a way, right? So I think so. People who think Edge AI is just IoT, it's not like that. If you're a mobile developer, if you are a suppose you're a specific web developer also, which is on obviously on compute, right? So you are an edge device developer, right? You can do whatever you build on top of it, and we all a lot of frameworks out there are almost ready. So it's not like it is coming; it is already there, and I'm still building on top of it, right? A lot of teams are working on top of it. Like we are doing a lot of hackathons and people building on edge AI experiences a lot actually, and it's just not only a very maybe a sci-fi kind of concept that you're living in that way, right? I can share one thing also, like a lot of people in our hackathon building on some biological bio or microbiolomolecule kind of work also on that particular, and using edge AI inferencing only, right? I know there's one team came in Noida. We did a hackathon in Noida some 2 weeks or 3 weeks back, and there's a team who actually created using our AI PCs and UnoQ, the same concept that what Omniverse, NVIDIA Omniverse, they did it. And they kind of replicated using Unity and that kind of thing. So people are working on it. HAI is already there. So, and the tools are up, documentations are up. And for documentation, forget documentation. You have MCP tools now. So you just have to call it out and you can start working with your cloud and all, right? So everything is there. It's just you need to start building on top of it. So yeah, that's just my final point as to it. Yeah.
Thanks. And I think, as the AI models also will become generic, as you rightly said, maybe in the 5 to 10 years, we are not talking about where, the AI is there. It is like, the expectation would be it is everywhere, including those smaller devices, including your mobile, and of course, in your laptop, and the cloud resources for sure.
Yep, definitely.
So thanks, Kartike, for joining and cutting through the hype and giving us, the full technical realities of on-device. Yeah. Thank you for joining.
Thanks for inviting me, Kuldeep. It's great talking to you again, a long time back. But yeah, thank you for inviting. Yeah.
That's it for this episode of Techie Talks with Kuldeep. Until next time, keep learning and keep innovating. Thank you for watching.